if I try to recapitulate what I have discussed in the previous class, so we started with the definition of system, surrounding, and the boundary. Then we discussed about the types of the system, like closed system, open system, and isolated system. These are the figure of different types of system. So what we learned till now, that a system can interact with the surrounding by two ways. One is the mass transfer, one is the heat or energy transfer. Okay, so based on that, we defined the system as a open system, closed system, and isolated system. Then we discussed what is the property of a system, and there are two types of properties. One is called intensive and the one is called extensive properties. Do you remember what is called state postulate? Can you recollect what is state postulate? Anyone? What is state postulate?
Yes, sir.
Can you please?
Yes, sir. A simple compressible system can be specified by two independent intensive properties.
Excellent. So that we discussed in the last class. So we know what is called intensive properties, and then we define what was the state of a system. State is basically identified by some specific values of the properties like temperature, pressure. Then we discussed about what is called equilibrium and the types of equilibrium, or mainly what are the driving force for a state change. So basically there are three types of driving force. This can be a thermal, four types of, like it can be a thermal force, can be a mechanical force, it can be a phase driving force or chemical driving force. This is the state postulate. Then we define what is called process, then path. Then I gave you the idea of called quasi-static process. Why quasi-static process was important, that is also discussed in the previous class. It is basically kind of a hypothetical process that is basically connected between the initial state and the final state by slowly changing the driving force. Okay, then we can only plot the points. So this was discussed in the last class. Then different types of processes. This is already known in your high school physics. Then we discussed what is the zeroth law of thermodynamics, and based on that, there are some illustrations. So these are the basic definitions. So hopefully you have read those topics, and we are entering in the next part. So that is basically the energy interaction. So in this section, we will be discussing the different types of energy interaction of the system with the surrounding. So already I told you in the previous class that the system can be divided into three types. First, classified into three types. The first one is called the closed system, which is most common, where there is no mass transfer, only heat and energy transfer. There can be open system where both mass and energy can interact, and there is isolated system, there is no kind of mass and energy interaction. Now if I consider one closed system, so how closed system can interact with the surrounding? By two ways. There is only one way, that is the energy interaction. This energy interaction can be classified into two types. One is called work transfer, one is called heat transfer. Do you understand? So I'm repeating that if I consider a closed system, whenever I talk about a closed system, that means it is not interacting mass with the surrounding. So it is basically interacting energy with the surrounding. So now the energy has two forms. One form is the work form of energy, another is the heat form of energy. So by these two ways, it can only interact. Like it can expand, so it is doing some work on the surrounding, or maybe it can absorb some heat, or maybe it can reject some amount of heat. So in this chapter, or in this today's lecture, we'll be discussing about these two type of energy. So what is work and what is heat? That is our today's discussion. So now, so what is work? So I told you there is two types of interaction. One is heat and work. So what is work? That is already known to us from our mechanics background. That if I apply some force on a body, and if the body starts to move in the direction of the force, we can say it is a work. And so basically in thermodynamics, what it is said that if some device or some instrument or some object is performing work, that work can be converted into a form that is equivalent to raising a weight through a pulley. This is a little bit complicated. Suppose this is one battery. If we look into the figure, the battery, and the battery is driving the motor, and the motor is driving a fan. So what is happening? If I consider this is my system boundary, so what is happening, that it is performing some amount of work. So in the definition of thermodynamics, can we say it that this is work? Yes or no? It can be only said that this is a work if I replace the pulley and simply fix a pulley. If I replace the fan and fix a pulley, and if I connected a weight through the wire, if this battery can lift the weight, that means it is performing a work. So it is basically what I'm trying to say, that how to recognize that which one is work and which one is not a work. The definition is that if some system is working, that means if you can replace the moving part and connect a pulley, and if that pulley can able to raise the object of a certain mass, that means it is performing some work. So we know what is the definition of work. So in the definition from the mechanics, what we know, that if some object is moving in the direction of force, it is a work. In the definition of thermodynamics, movement is there, but that movement should able to cause a raise of weight through a pulley. So those are similar thing. Now, in the simple compressible system, or maybe initially we have to focus on the simple compressible system. Basically, I'm talking about a piston system. So if there is a piston, if the gas which is basically inside this piston, it has some amount of kinetic energy, the molecular kinetic energy. So due to this molecular kinetic energy, if we apply some heat, the molecular kinetic energy will increase. This gas particle will bombard on the surface of the piston. So that will cause a net momentum change, and that net momentum change will generate a force, and that force will cause an expansion. So similarly, if I extract some amount of heat from this gas, what will happen? The particles will start to lose its energy. So what will happen? It will bombard the surface with a less momentum. So what will happen? This piston will not feel that much amount of force from the left side. So the volume will decrease. So this is the microscopic view of the thermodynamics.
স্যার একজন ঢুকতে চাইছে স্যার, প্লিজ যদি এন্টার করে নেন।
So it is now 6:15. Okay. So what I was trying to say, that this molecular kinetic energy is finally converting into pressure. But thermodynamics can be studied in two ways. One is called the microscopic approach. One is called the macroscopic approach. What do you mean by microscopic approach? In the microscopic approach, you are looking each and every particle, and based on that, you are explaining any phenomena. But whatever thermodynamics we are going to study in this course is basically the macroscopic thermodynamics. Macroscopic means you are not looking into the molecular level. You are looking into the little bit higher level where it is like a phenomena. So you are not looking into the microscopic behavior of the molecules. So in this section, we will be looking only into the macroscopic part. But if you read the statistical thermodynamics, or maybe some part of the quantum physics, those are basically the microscopic way of looking in a phenomena. But in this course, we are not going to look into the microscopic phenomena. So we are going to look into macroscopic phenomena. So what is happening? These particles are hitting in this wall. So finally, what I am assuming that basically some pressure is being generated in the cylinder, which is basically pushing this piston, and due to this force, the piston is moving in the rightward direction. As the piston is moving in the rightward direction, so there is a displacement. If there is a displacement, so it is performing some amount of work. So we know what is work. What is basically, it is related to the force and displacement. So basically, whenever there is an expansion, or maybe whenever there is a compression, so there must be some work. You understood? Because I told you that work means motion associated with a force. So what is the force? It is basically the pressure and the area. So if you multiply pressure with the area, you will get the force. So what is pressure? Pressure is basically force per unit area. So if you multiply pressure with the area, I will get the force. And if we multiply this pressure into area into the displacement, you will get the total work done. Because I know from the definition of work, force into displacement is my definition of work. So this is basically called the moving boundary work. So this is one form of work. There are several forms of work. There can be electrical work, there can be shaft work, there can be magnetic work. So there are several forms of work. In this section, we will be dealing with the only mechanical form or the moving form of work, moving boundary form of work. There can be also other mechanical form of work, like a spring work. It is basically a mechanical form of work, just like what you have studied in your mechanics in your plus 12, that if there is a spring, it is performing some work. So that half into kx square is the potential energy. So that is basically the mechanical form of work. But in this section, we will be dealing a special type of mechanical work, which is basically called the moving boundary work. Now, so how to calculate this amount of work? I told you that we know the initial state and the final state. So in the initial state and the final state, we will assume some equilibrium state. In those equilibrium state, what is going to happen? The driving forces change in a very small amount. That small amount is causing a intermediate temporary equilibrium. So by which we can locate those all small points and connect through a line. Then only we can draw a path. So path is very important for mechanical work. So just like what I gave the example in the previous class, like this is a piston and this is basically the weight. So what you can consider, this weight is nothing but some 1 rupee coins, some stack of 1 rupee coin. So you are not removing the complete weight, gradually removing 1 and 1 coins. So what will happen? The mg will reduce. So finally the gas will expand. So basically every time you are basically dividing the driving force into small amount of driving forces. And those forces you are gradually changing. So you can achieve the intermediate equilibrium. So this is basically called the quasi-static process. Anyway, this concept is already known to you. So now, if I got the process, so how to find out the work? If we look at the diagram, that in the PV diagram, I have one point. This point has a specific P and specific B. So by this P and V, you can locate the point. How I can say that this is sufficient P and V, because from the state postulate, we know that we need two intensive properties that can locate a state. So one point is a unique point. Now we know that work done equal to F into ds. ds is the displacement. So F is equal to the force, P into A. ds is the displacement. So A into ds. So what is A into ds? A is the cross section area of this piston and ds is the displacement. So basically, if you know the cross section area and the length, so basically it is talking about kind of a, if it is a circular cylinder, it is basically talking of a kind of semi cylinder. So it is basically cylinder kind of a volume. It's like something like a pi r square into dl. Okay, so this A into ds is getting multiplied and converting into dv. So that's why we call that work done in a piston work is basically P into dv. So if 1 is the initial state and 2 is the final state, so the work done, total work done is basically the integration P dv. Why it is called P dv? Because everywhere what is happening, the pressure is changing. So if your pressure is changing, so at any instantaneous point, if you have dV volume and the instantaneous pressure is basically P, that area of this rectangle, area of this small rectangle, just like what you have learned in your definite integral, we assume small rectangles, and if we sum up those rectangles, we will get the final area under the curve. The same thing is happening there. So basically the work done P into dV is basically represent the area under the curve of a PV diagram. So if I move from the process 1 to 2, there will be a path. In this path, there will be an area under this path. This area is basically representing the amount of work that you have done to reach from 1 to 2. Is that right? Now, another important thing is there, which is very crucial, what is basically called the sign of the work. Sign means is it positive or negative? What is the definition of work? Whenever a piston is expanding, so it is doing work on the system. So basically it is transferring energy from its own inside to the outside. This any kind of expansion work is considered as positive. And if you compress the cylinder, compress the gas, so you are doing work on the system. So whenever you are doing on the work on the system, it is considered as negative from the perspective of the system. So like why it is like this? It is just an assumption or convention. So in the engineering thermodynamics approach, whenever a gas is expanding, it is considered as positive work in the context of the system. Whenever you are compressing the gas, you are doing work on the system, it is assuming that this work is basically negative. Again, why it is like so? Because it is like just like a convention. This convention is valid for engineering thermodynamics. If you read the chemical thermodynamics, they have a reverse convention. So, but whenever you are studying one subject, you have to follow one convention. So just like that, suppose if you see the bottom diagram, the first one, you are moving from 1 to 2. Whenever you are moving from 1 to 2, your initial volume is V1, the final volume is V2. So which volume is higher? The V2 has a higher value. So basically it is an expansion work. So this pink area under this diagram is basically a positive work. And this area is also a positive quantity. Now, if I think about my 1 is my initial point and I am compressing the gas. As I am compressing the gas, what is happening? The volume is reducing. As the volume is reducing, the pressure is also raising. Due to this, I am moving from a higher volume to a lower volume. So this is a negative work. Is that right? There can be a process where the pressure can remain constant. So if I see the third figure, it is moving from point 1 to 2. So the area under this rectangle is defined as the positive work because the initial volume is low, the final volume is high. So this work is basically a positive work. So whenever a system is expanding or system is doing some work on the environment, this work is considered as positive. But if the environment is doing work on the system, this work is considered as negative. If I go to the next slide, another important thing is that, so as we know that the work is defined as the area under the path. So if I consider one point, this 1 and 2. So if you go from the point 1 to 2, following a path A. So basically, suppose you are at Ruby Hospital and the point 2 is basically your university. Okay, so how you can reach to your university? By moving to the Ajaynagar, from Ajaynagar, taking an auto to the Shukanto Setu, and from there you can reach to your university gate number 2. So this is one path. In this path, the area under the diagram is basically the work done for this path. So which is written as 10 kilojoule. But from Ruby Hospital to university, you can directly move to Gariyahat From Gariahat, you can take another auto which will move to Goal Park and finally reach to your gate number 4, and from which you can reach to the department or somewhere. So this is also another path. So this is basically the path 2, the same initial point and the same final point. You are reaching from the point 1 to the point 2 by 2 different processes. So what do you mean by different path? Because intermediate points are different. Okay, so based on that, you can get a different work. So what you understood, that the point 1 and the point 2, two different points are there. You can reach from the point 1 to point 2 by several paths, and for each path you can have a different work. So whenever you are saying that like if you say that what is the distance between Jadavpur University and the Ruby Park, you have to mention that which path you are following. If you are traveling by a car, the Google map will show you a different distance. If you are traveling by a cycle, the Google will show you a different path and the different distance. So similarly, for the work done also, this assumption is valid. So that's why work is called basically the path function. Is that right? Suppose you consider that, what you can consider that that the latitude or maybe the coordinate. Suppose you consider that the coordinate or of the Ruby and the Jadavpur, if these 2 points has a different coordinate. So now if we reach by path A or the path B or the path C, the coordinate change that will remain same. Suppose it is a 1 point and 2 point. So if you whatever path you follow to reach 1 to 2, the coordinate will not change. In that case, you can say that the coordinate is not dependent on the path. So it is called, the coordinate can be called as a path function. You got my point? Suppose you know the temperature of the point 1 and or maybe the volume of the pressure. You know the pressure of the point 1 and you know the pressure of the point 2. Whatever path you follow, finally the delta P will remain same. So the pressure can be called as a point function. Whatever path you follow from 1 to 2, the change of volume is same, delta V. So my volume is a point function. But if you go from the point 1 to point 2 by path A, path B, path C, for all the cases, the work done is different. So that's why the work done is basically called a path function. So if I consider a PV diagram, so this is the point 1, this is the point 2. So what you are doing, you are moving from 1 to 2. You are moving from point 1 to 2 through the path B. After reaching the point 2 you are coming back to the point 1 through a path A. So due to this process, the net area under this curve is basically the W net that you have given to the system. So that much work. So if you are moving from the point 2 by this path, if you are moving from the point 2 to the point A through another different path, so in the area under the curve 1 to 2 is a negative work. Area under 2 to 1 is a positive work. So if we sum up this, you will get this net work. So this amount of work will be done by the system. Work done by the system. Why? Because this work is a positive. Because this upper curve has a higher area under the diagram and the lower curve has a lesser negative amount of work. So if we sum up these two, it will finally give you a positive work. So that's why this area under the cycle is basically a positive work. But if we consider the point 1 and 2 in a reverse way, you are moving from 1 to 2 through the path A and 2 to 1 through the path B, the net work transfer will be a negative work. So what I can do, I can wait for 2 minutes. If you have any doubt, you can clarify it now. I'm waiting for questions. Any questions? Any queries? Any slide that you want to that I should repeat? Okay. Any other questions? Which one?
Sir.
Yeah.
Sir, are the processes you mentioned that the point function is the point function and the state function same?
Point function or state function are the same.
Okay, sir.
Point function can be referred as a state function, but path function is a different thing. So we have to understand what is called cyclic process. The definition of cyclic process that I should mention in your previous class, maybe I have forgotten that what is cyclic process, that if you start from a point, you are passing through some different points, and if you're coming back again to the initial point, that process is basically called a cyclic process. So if we see the right side diagram, you are at the point 1 and you are following a path B. By this path, you are moving to the point 2. Now the question is that this is a compression or expansion? This is a compression. So as it is a compression, because you are moving from a higher volume to the lower volume, during this process, there will be some negative work. That means there will be some work done that is done on the system. So you are from the outside, you are working on the system. So basically it is a compression. Now, whenever you are moving from the point 2 to the point 1, so what is happening? The gas is expanding. So the system is doing some work. So if we sum up these whole two processes, finally you will see there is a positive work. So if we go from the point 1, from 1 to 2, 2 to 1, during this whole cyclic process, the system will perform some work on the environment. That is reduced by this work. This much amount of work will be done by the system on the surrounding. So how you are sure that this work is done by the system? Because this work is a positive work. Why this work is positive work? Because this final area is an expansion work, and this is having a higher area under the diagram. So this whole area is basically the area. If I draw a single hatch, so there is a horizontal hatch, and this line will give a vertical hatch. So if we subtract these two parts, then finally we'll get the net positive work.
Sir, যদি পাথটা উল্টো স্যার,
হ্যাঁ বল,
যদি পাথটা উল্টো হতো মানে 1 থেকে 2 তে যেটা মানে প্রথমের ওয়ার্ক ডানটা বেশি হতো, তখন তো ওয়ার্ক ডানটার সাইন উল্টে যেত।
So if I move from the point 1 to 2 through the path A, simply reverse this arrow. If I move from the point 1 to 2 through the path A, that means basically that is a compression. This compression is a negative work. And if you are moving from 2 to 1, it's a expansion work. This is a positive. So if we now sum up these two work, this final area under the diagram, that will be a negative. So basically, if we follow 1 to 2, then 2 to 1 by initially A and finally by B, then the system needs some work from the external. Then only it can perform the process. So in that case, the sign of the work will be reverse. It will be a negative work. So these things I'll come to later further by solving problems. So hopefully you understood. If you have still any doubts, you can clarify it. This part is a little bit tricky to understand. Shall I proceed?
Yes, sir.
Okay. If you have any query, any questions, you can post in the chat box. I will try to reply. Please make it interactive. Otherwise, it will be very boring for me because I am not able to understand that who am I teaching sitting in front of a laptop screen. So now, just like I told you that there will be several processes, and for several processes, will follow a general rule. What is the rule? That is a PV to the power n equal to constant. What do you mean by that? That if there is one variable pressure, there is one variable volume, and they have a relation. That relation is basically some constant. So suppose if I tell you that n equal to 1, so PV equal to constant, that is a process. What is the meaning of that? That during that process, pressure is inversely proportional to the volume. This PV to the power n, it can be PV to the power 2, PV square equal to constant. Based on that, what are the intermediate points by which it is passing? And it also depends upon the process. Suppose it is a constant pressure process, it will be P equal to constant. This n will be equal to 0. So based on the different processes, the parameter n changes. Is that right? So if I try to work done, what is the work done for a polytropic process? So if it is a polytropic process, this process is basically called a polytropic process. That is basically the general expression of work. If I try to make it simpler, so what I can do, if I try to show you some so suppose this is a constant pressure process. For constant pressure process, W1 to 2 is basically expansion of V2 P dV. As the pressure is constant, the P will go outside the integration. So finally the V2 minus V1 is basically the work done. So that is shown in this figure. You can see this figure. So just like this, if we consider a constant volume process is basically called the isochoric process. So in the isochoric process, if your volume is remain constant, initial volume and the final volume is same, you can say that this is an isochoric process. If it is an isochoric process, there is no expansion. If there is no expansion, there is no mechanical work. So finally, this dV will become 0. So your work done will be 0. If I show you another example, so this is the example of isochoric process. You are at the point 1 with a pressure P1. You are moving from the point 1 to the point 2. During this process, your volume remain constant. So basically it is following the same vertical line. If it is like this, there is no expansion. If there is no expansion, no compression, no mechanical work, or no positive displacement work, or the moving boundary work. If it is following the PV equal to constant, the isothermal process. So what will happen? If it is the isothermal process, so integration P dV, that is basically your work done. So you know that PV equal to P1, V1 equal to some constant. So if we take out the constant and put in the place of P, so what will happen? This P1, V1 by V will come. P1, V1 equal to constant, so that will go outside the bracket. So finally you have V1 by V2 integration dV by V. So if we integrate it, then dV by V will give you ln V2 by V1. And we know that V is inversely proportional to P1, P. So V2 can be replaced by 1 by P2 and V1 can be replaced by P1. Like 1 by V1 can be replaced by P1. So it will finally become P1 V1 ln P2 by V2. P1 by P2, or maybe it can be written as ln V2 by V1. So if you're talking about it is expansion work, so ln V2 by V1, if V2 is high and V1 is low, then only this term will be a greater than 1. If it is a greater than 1, it will come as a positive value. If the V2 is small and the V1 is large, so it is basically a compression. So if it is a compression, this will become a fraction, and we already know that ln of fraction is what? Negative. So it will be a compression. So the sign of work is already incorporated there. You don't need to bother about the sign of the work. The sign of the work is already taken care inside the expression. So similarly, what I was showing in the previous diagram, that PV to the power n equal to P1 V1 to the power n equal to P2 V2 to the power n equal to C. So in this expression you can find out P. What is your objective? Your objective is that I have the expression P dV equal to PdV equal to what? PdV equal to my integration of PdV equal to my work done. So you have to replace your P with some function of V. Then only you can integrate. So in this expression you have P, you replace this P by P1 V1 to the power N by V to the power N. Now there is no P. Yeah, there is a P, but this P1 is a constant. So you can simply take out the bracket. You can take this term outside the bracket. So it will be 1 by V to the power N into dV. So finally this expression will come. So this is for a polytropic process. So what I was trying to show in the slides, that polytropic process is basically the general expression of work. So if I simplify this term, you please do it at your home. If we simplify this term, finally it will come as P2V2 minus P1V1 by 1 minus N. That will be the expression of work done for polytropic process where N is not equal to 1. If your N equal to 1, what will happen?
Infinite work done.
Infinite work done. Completely wrong answer. Any other?
Isothermal process.
Very good. Excellent. So if your N equal to 1, then this mathematics is not valid. So basically in that case you have to move to this expression. You already have done it. So this will be this. See already your PdV.
I have a question.
Yeah.
In a polytropic process, the work done, is it a path function?
Every kind of work done is a path function. The path is basically denoted by the value of N. I'm just showing just one diagram. It will be much easier for you. That if we see this diagram, see, this is the general expression of polytropic process. If your N become 1, it will become an isothermal process. If your N becomes 2, it will become a quasi-static process. This will become a PV square process. If your N can become 3. If your N becomes 0, it will become an isobaric process. And if your N become infinity, it will become a isochoric process. Just like your expression already you have known, like x to the power n plus n into x to the power n minus 1. So this is the general expression of binomial expansion. You have already done it. X plus y whole to the power n.
Sir, can isochoric and isobaric processor not be quasi-static? In the diagram, it is not shown.
Why it was saying it like this? How you are sure that this is not quasi-static?
Sir, because if the pressure is constant, then if the volume changes, the temperature will also change. So how can equilibrium, temporary equilibrium be maintained?
What you are trying to say, if you think about any process, if you think about P and V, other than this N equal to 1, listen to this very carefully. If you consider this N equal to 1, other than N equal to 1, for all processes where N equal to 0, N equal to 2, N equal to 3, N equal to infinity, for all processes, your temperature is changing. Temperature changing, it doesn't mean that it is not an equilibrium process. There is nothing called equilibrium process. There is a definition that is called equilibrium state. So what do you mean by equilibrium state? This point 1. In this point 1, the temperature inside the whole system is constant. That means though no temperature difference at the state 1 inside its volume. So it is basically presenting a homogeneous temperature inside the body. This is called thermodynamic equilibrium. If you talk about the point 2, at this point 2, whole temperature, pressure, phase, chemical, everything is at unique value or at homogeneous value. That is basically called thermodynamic equilibrium of state. But there is nothing nothing is there which is called as equilibrium process. Do you got my point?
Yes, sir.
So for any process, temperature can change for any process other than isothermal. Isothermal is a special type of process. For a process, whenever you are moving from point 1 to point 2, if you are moving from point 1 to point 2, the temperature will change, the pressure will change, the volume will change, the entropy will change, enthalpy will change, everything will change. Then only we will reach to the other state. You got my point? But there are some special cases. What do you mean by special cases? Where everything is changing, but only the pressure is not changing. That is basically called the isobaric process. So these are some special cases. But naturally, in reality, most of the processes are polytropic process, where everything is changing. But whenever you started the process, at that instant, everything inside the volume 1 is homogeneous. Whenever you have completed the process, end of the process, if you look into the volume, everything comes to a standstill condition. That is basically meant by the equilibrium, the definition of equilibrium. But intermediate the process, everything is changing. But what do you mean by quasi-equilibrium? That every time it is changing slowly. That's why you can locate the points. Otherwise, you can't locate the points. Just like I gave you the definition at the initial class, that if you see, this is a equilibrium, quasi-equilibrium processes. Whenever you removed one coin, the pressure changes. After changing the small amount of pressure, the system will come to equilibrium. So it is basically, the big process is basically you have divided into small processes. Every time it is completing a process, comes to equilibrium. Initial state is equilibrium, intermediate, there is a small gradient of force, and finally after reaching to that point, it is reaching to equilibrium. Again, you remove the other coin. So another driving force generated, that driving force is causing a change. Due to that, it is moving from the point 2 to point 3. After that, it is coming to equilibrium. Then you remove the other coin. So it is moving from the point 3 to the point 4, and after reaching to the point 4, it is again coming to the equilibrium. After that, you remove other coin, it is moving from the point 4 to the point 5. So it is happening gradually. So the big amount of driving force you have divided into small gradient force. Then only you can reach from the final state 1 to the state 2. But during the process, it is never at equilibrium. If it is during the process, it is equilibrium, then it is there should not be any kind of state change. Okay. Think about this. If you have further doubt, I can clarify it. So, any doubt up to this much?
Sir, can the value of n be negative?
What is your opinion?
Actually, in our JEE days, we used to face some kind of problems where P by V square equals to constant, and then derive the relation between V and T.
Very good.
So actually, I don't have any idea, because I think it can be theoretically possible, but practically it is not possible. So I have no clear-cut idea about it.
Okay, so basically, you have to understand one thing, that you have a P versus V diagram. You know the initial point and you know the final point. These 2 points are known to you. So what you are doing, you are slowly moving from the point 2 to the point 1. From the point 1 to the point 2. Whenever you are moving from the point 1 to point 2, it is passing through some intermediate points. As it is passing through the intermediate points, which intermediate points it will follow, that will depend upon how you are transferring heat and work. You got my point? So why is a system changed its state from 1 to 2? Because you have some driving force. That driving force causes a typical intermediate points through which it will pass. Suppose I'm giving one example. Suppose just consider that you are going to Goal Park. So now, as you are going to Goal Park, what you can do? You have a car, or you want to avoid the jam. So what you can do? You can simply go to bypass. From the bypass, you can take that Ruby. From Ruby, you can go to Gadiahat. From Gadiahat, you can go to Goal Park. As you have a car. So as you have a car, you have several different points, several intermediate points. What are the intermediate points? Shulekha, Santoshpur, Ajaynagar, Ruby, Acropolis Mall, then you are getting to Gadiahat. So these are the intermediate points. Suppose if you have a cycle, simply, or you have auto, simply you will take the auto and auto rickshaw and finally reach to Gadiahat or Goal Park. So there are several intermediate points, but which is deciding these intermediate points? Your financial strength. If you have a car, you will take that route. If you have an auto, you will take that route. If you have a cycle, you have some intermediate Dhakuria station road and you will reach to Goal Park. So simply for any process that will reach from 1 to 2, which intermediate points that it should follow, it will depend upon that what are your driving forces. Okay, so now you will get some intermediate points. After that, you can fit a polynomial. We know that if I have multiple points, I can fit a polynomial just like x and y. So you have y equal to some function of x. As you have some y equal to function of x, if we try to fit the polynomial, this polynomial can be pv to the power n, pv to the power minus n, pv to the power minus n. It can be anything. So by which there can be a possibility where this n can be negative. There is no issue. Theoretically, you can get any n. It is just like a regression. You have done regression, fitting a polynomial. This polynomial can be, the value can be anything. So it is just like a polynomial. You don't need to bother about that, how the processes happen. But or something like you can say that how I can create a process that can create a negative n. That you need to imagine. That is very difficult thing. But I am not bothered about that. For me, it is simply a mathematical relation. By this relation, I will perform my integration and finally get the answer. I will show you some example where you can see that this n can be anything. It is something just like a correlation, or it is something like a regression. Whatever n it can be, it depends upon that what are the intermediate points. Any other questions? Any other questions or anything that you want to ask? Whatever that comes to your mind, you can ask.
So can the n be a fraction?
N can be a fraction, yeah. N can be anything. I told you that it can be 0, it can be infinity, it can be anything.
So that means any real number.
Any real number. N can be pi. Like it is something just like a curve fitting. You have some intermediate points and you are trying to fit the curve. Whenever you try to fit the curve, this n is basically the fitting or the tuning parameter. Whatever the tuning parameter that will give the minimum error. You have from statistics you know what is called the least square method. So whatever the least square will give you, that n value will be that. But if we try to imagine that how this what I will do, that will force the gas to follow a path that will create a fraction, that is little bit complicated. You need to think about that. There are some processes where you can get n can be a fraction, anything. I will show you one example. Like what is our common convention? In common convention, if my volume increases, what will happen to what will happen to the pressure?
Pressure will decrease.
Huh?
Pressure will decrease.
Pressure will decrease.
Yes, sir.
Everyone is agreed with this? If my volume increases, what will happen to my pressure?
So it will depend on mass and temperature.
Mass is constant.
Temperature also it will depend.
Temperature, yeah, that is okay. But what is our common intuition that if my volume increases, what will happen to my pressure?
But if mass and temperature constant, then
Mass, it is a constant mass, dude.
Then it will decrease. Volume increases, pressure decreases.
So it depends upon the N.
Depends upon the N. You forget about the N. N is basically kind of a post processing. After getting the process, then we feed a polynomial, then we get the N. So yeah, your point is true that will depend upon the N, but I'm trying to say what is your common intuition that if my volume increases, my pressure will change. So if someone asks me that, so there can be a possibility that my volume is increasing, but my pressure is increasing. Is it possible? Don't say ambiguous answer that temperature will increase, depend upon the temperature. Like, tell me a physical example. Just what was previously was asked. I am showing you one example. See, just I'm showing you one example. It was very interesting. When I found this one, I found that it's very interesting, non-intuitive. I'm showing you that example. Think about this process. Suppose this is a cylinder. This cylinder is filled with some gas. And there is one hinge or maybe a cantilever through which you have connected one spring to this. Now, if we supply heat, what will happen? Is it visible?
Yes, sir. It will expand.
The gas will expand. Is that right?
Yes, sir.
Because you are putting more kinetic energy. As you are giving more kinetic energy, what will happen?
The gas will expand.
Gas will expand. But there is a spring. So what will happen?
It will try to oppose
the expansion.
Oppose the expansion, but the gas will expand. But as the gas is expanding, what is happening to the spring force?
It is increasing.
Spring force is increasing. So what is happening?
The pressure is increasing.
So it can be a possibility. So which is non-intuitive. So just like what I was trying to say, that someone is asking that, can I get a situation where my N can be negative? Can I get a situation my N can be fraction? It will depend upon the arrangement. How you are creating that arrangement. That is forcing the gas to follow that path. Are you getting my point?
Yes, sir.
So in this case, what is happening? Your volume is expanding. As the volume is expanding, it is compressing the spring. As it is compressing the spring, I know that my spring force is equal to minus K into X. As my X is increasing, what is X? The displacement or the deviation from the natural length. As my deviation from the natural length is increasing, the downward force that is also increasing. So this is happening simultaneously. So it is counterintuitive. You got my point. So that's what I was trying to say. So just now, any other question? Any questions? There would be a logarithmic term from the integration. Okay, fine. The previous question. Any other question in the chat box? Okay, so shall I continue for more 10 minutes, 10, 15 minutes?
Okay, sir. Yes, sir.
Yeah. Fine. Thank you. So, so in this section, I have discussed about the convention of work the moving boundary work, how to quantify the moving boundary work, and how to understand the sign of the work. So initially I started with 2 points: energy interaction. One is the heat interaction, one is the work interaction. Work interaction has several parts. One of this is a moving boundary work. So I have discussed about the moving boundary work. Now I have another remaining interaction. What is the remaining interaction? The heat interaction. So heat interaction. So let's understand the heat interaction. So if there is a cylinder and if you are supplying some amount of heat, what will happen? The temperature will increase, then the gas will expand. So heat interaction is also a form of energy interaction. So now we know that this will also depend upon the path, like how you are transferring this heat. So suppose, just like in the previous case, that suppose you have one point, you have another point, you can reach from the point 1 to point 2, transferring different amount of heat. It is also a path function, just like I have discussed in the previous class. If it is P, it is a V. If I transfer, if I follow a path 1 to 2, it will give a different amount of heat interaction. If I follow the path 1 to 2 through the path B, it will give me a different amount of heat interaction. If I follow the path 1 to C, it will also give me a different amount of heat interaction. Why it is such, I will explain later. It will take 2 or 3 more chapters, but I want to mention that heat interaction is also a path function. Which path you are following, that will give you the net amount of heat interaction. And we know that what is specific heat? Specific heat is basically the total supplied heat by the mass. And heat interaction is also having a sign. What is the sign? The sign is very interesting. If I supply heat to the system, the heat transfer is positive. If the system rejects heat into the surrounding, the heat transfer is negative. Similarly, for work, if the system work done on the surrounding, it is a positive work. If the surrounding done some work on the system, it is the negative work. So heat is positive when it enters into the system, negative when it leaves the system. And for work is positive when it is done by the system, and it is negative when it is done on the system. Any questions? Do you understand the convention? Should I repeat
Hello,
it?
sir.
Yes.
স্যার বলছি যে মানে এই কিউটা গ্রেটার দেন 0 লেস দেন 0, স্যার এই কনভেনশনটা কি সেই আবার সিস্টেমের পার্সপেক্টিভে আনা হচ্ছে যে মানে এনার্জি বেড়ে যাচ্ছে হিট ট্রান্সফার?
You don't try to think about that. The net energy is increasing or decreasing, that's why it is positive, that's why it is negative. You don't remember this. You simply remember the convention. Okay. There is no reason for this convention. Okay. If you follow the chemistry books, it is having a different convention. So in the context of chemistry, the work done sign is negative. So that's why you don't need to think about what is the procedure of what is the convention. You simply remember the convention, but you don't need to figure out why this convention is taken. And if there is no proper reason that why this convention is taken. So it is a convention. If I follow this convention, then only all of my whatever rules I am getting, those rules, formulas, those are valid only you assume this convention. So okay, all the convention, if we see Q, this Q is basically heat transfer. If your heat transfer to the system, if you see that the system is transferring heat, you have to put a negative value there. For that we need this convention. Okay. So few things that I need to read down. So this is the this is the class. Read the points very carefully. The first point is that heat transfer and the work transfer are the energy interaction. A closed system and its surrounding can interact in two ways, by heat transfer or by work transfer. Thermodynamics studies how this interaction bring about the property changes in a system. So I told you that if I have a closed system, this closed system only interact with the surrounding by energy transfer or work transfer. Okay. So next, the same effect in a closed system can be brought about either by heat transfer or by work transfer. Whether heat transfer or the work transfer has taken place depends on what constitutes the system. Like I am giving one example. So what I can say that suppose I live in my home. So in my home, what my parents can do or what I can do that suppose you want to gift something to your friend. Okay, so that will increase the happiness of your friend. So what you can do, you have two ways. Either you can transfer some money or you can simply something purchase on the Amazon and gift it to your friend. So there can be a cash transfer or there can be a kind transfer. But finally, after reaching that cash, your friend is going to buy a laptop or television, or either what you can do, you can simply order that laptop and send it to your friends. Out both of this, the happiness level of your friend is going to change. Initially, he was very depressed. After taking that laptop, he is very happy, or he or she is very happy. So basically, the happiness, if it is the state of the system, initially he or she was very sad. Finally, he or she is very happy. These are the states of the mental states. How it can be changed? Either you transfer some money by which he or she can buy a laptop that will bring his happiness, or you can simply order a laptop and send it to your friend. So similarly, a system can have a state 1 and state 2. You can change the state either by heat transfer, either by work transfer, or some heat transfer and some work transfer. But if you want to change the state from state 1 to state 2, you have only two ways. Either it is a heat transfer, either it is a heat transfer, either it is a work transfer. Is it okay?
So last point,
last sentence ta hoche, suppose if it is a state 1, a system is staying at state 1 and this is the state 2. You want to move from the state 1 to state 2. Why a system change its state? Because there is a driving force, or maybe there is a inequilibrium with the environment. The environment causes to change its state. So how environment will influence the system? Either it can transfer from some heat from the surrounding that will cause the system, that will force the system to change its state from 1 to 2. Or maybe the environment will perform some work. Due to this, the system will change its state from 1 to 2. Or maybe there is some partial heat transfer, some partial work transfer. Due to this, the system is changing its state 1 to 2. But whenever the system changes its state from 1 to 2, there must be either a heat transfer, either a work transfer, or both. Other than heat transfer and work transfer, system cannot change its state. That is why the isolated system never changes its state. You got my point?
Okay, sir.
So that's why it is said that the heat transfer and the work transfer, they are boundary phenomena. It happens only at the boundary. It is very interesting that it is wrong to say number 4, if you read the point 4, it is very interesting that it is wrong to say that the total heat or the heat content of the closed system, because heat and work is not a property of the system. You got my point? So what it is trying to say, the system can have some energy at the state 1 and the system can have some amount of energy inside. But this energy transfer takes place through heat and work transfer. The system can never possess some amount of heat. System can possess internal energy. It cannot possess heat and work. It is completely wrong to say that this system is having high heat. No, it is wrong, because heat can only exist at the boundaries. Whenever I want to, suppose I can just give you I can give you some illustration. Like suppose I have suppose consider my mental state. My mental state is sad and someone having a mental state which is very happy. So now this is two different states. Now if I want to change the mental state for me, suppose I want to become happy. So if I want to become happy, what can be done? I need some money transferred to Google Pay, or maybe some gadget, maybe a mobile phone, through which my mental state can change from sad to happy. So this is the change. So happiness is basically the internal thing. This internal thing can be changed by either some gadget or some money or some cash. So this thing can happen. But whenever the gadget comes to my room, this became happiness. This is now not gadget. This became a happiness. So whenever the heat enters inside the system, it becomes internal energy. It is not now it is not heat. Whenever the system loses some amount of energy, loses some amount of heat, the heat never reduces. The internal energy reduces. Whenever you are working, you are doing some work on the system. Whenever you are doing some work on the system, at the boundary it is work. Whenever the work comes inside the body, it became internal energy. You got my point? So that is why it is told that the heat and work are the energy in transit. These are basically currency. These are basically equivalent to currency. Okay. Number 5, heat transfer is the energy interaction due to temperature difference. Other than all other energy interaction can be termed as a work transfer. Whenever you are transferring heat, whenever you are placing your object into some near about surrounding, if there is a temperature difference between the system and the surrounding, there will be a heat transfer. Other than any kind of interaction of the system with the surrounding is basically a work transfer. So basically, what is the meaning of this? It is trying to say that energy interaction for heat transfer, the temperature difference is the necessary. If you have a same temperature, if your surrounding and the system, if they are same temperature, but still you want to transfer energy from there to there, in that case you have to go for a work transfer. You can't go for a heat transfer. If there are the temperature difference between the body 1 and the body 2 are different, then only you can have a heat transfer. Okay, the last point is that both heat and work are the path functions and inexact differential. the magnitude of heat transfer and work transfer depends on the path of the system during the change of the state. So what do you mean by inexact differential? So suppose if I have an integration dv 1 to 2, if I write it v2 minus v1, it is basically called a exact differential. But the integration of dv, if it is cannot be written as v2 minus v1, it is basically called a inexact differential. So simply what I was trying to say that whenever you are writing this expression integration 1 to 2 dq, you cannot write it is as q2 minus q1. Integration 1 to 2 dq, you cannot write it as q2 minus q1. Why? Why it is so?
Sir, it will depend on the path.
Exactly. So how? Yeah, exactly. I can continue.
No, sir, I was just saying that it does not depend on the path.
Exactly. So you are, so basically what it is trying to say that there is nothing called q2. If q2, if I just, you consider this expression, if I write down integration 1 to 2 dv, I can write v2 minus v1. If I write it p2 minus p1 dp, I can write p2 minus p1. But if I have integration 1 to 2 dq, I can't write it, it is q2 minus q1, because q is not a state function or a point function. If it is a point function, then only I can write q2 minus q1. So basically what I'm trying to say, that work and heat, these are not properties of the system. You got my point? Like pressure, temperature, these are basically the properties of the state. But Q and W, these are not properties. These are basically some way through which the system change the set of properties or the state. So that is why it is basically called the path function. How you are performing the process, based on that it will happen. It cannot be expressed as the difference between the final state minus the initial state. You can't write it like this. You got my point? So this is the thing. The heat and work are the path functions, and it is inexact differential. So you understood the meaning of inexact differential? If you write it like y2 minus y1, it is an exact differential. But if you are not allowed to write it y2 minus y1, it is basically called the inexact differential. So this is the summary of heat and work transfer. So what today we have discussed? Today we have discussed the heat and work transfer, then moving boundary work and how to quantify moving boundary work, then work done through a PV diagram, then the sign of the work and the work path function, then the expression of polytropic process, and how to find out the work done for any process. This is nothing but some mathematical skills or mathematical exercise. Then we discussed about heat transfer and the sign of heat transfer, and finally some major point. The major point is that the total heat transfer, there is nothing called total heat. There is a word called total pressure, total volume, total energy, but there is nothing called total heat, because heat only exists or work only exists at the boundaries. The system can never have a work. The system cannot have a property like a work, or system cannot have a property like heat. It can have a property like density, temperature, volume, pressure. These are the properties. Heat and work are not the properties. These are the medium through which the system change its state from 1 to 2. So this is the this is for the today's class. I like to take questions. If you have any doubt, I can stop the recording. Any questions? Any questions? Am I audible?
Yes, sir.